Hey, we're live. This is Toby, and we're gonna continue walking through this LLVM tutorial. The tutorial is called My First Language Frontend, and we're in the middle of chapter 2. Chapter 2 is quite a lengthy chapter, and right now we're in the middle of it in the section called the binary expression parsing. So we're gonna write the part of the parser that parses binary expressions. What are binary expressions? Well, there's something like that, but I mean, this is one binary expression, but it could be more complicated. It could be like that. Now, as the author talks about, when you have something like this, should the parser parse it as this operation first or this operation first? Well, in math, as mathematicians, or as we're taught in school, multiply has higher precedence than addition, right? So based on that rule, then this should get higher precedence. How do you implement operator precedence in parsing? Well, there's multiple ways. This tutorial is using a method, a technique, which is, I believe it's called the shunting yard algorithm, which I'll show you how that works. It's based on assigning each operator type a number to represent its precedence. So you can see this tutorial recommends using a map to store the precedence number, like the precedence value for each operator. So the less than operator gets 10, the plus operator gets 20, and so forth. I'm actually thinking, instead of doing this, I'm just gonna write a switch statement. I think that would be simpler, although I have nothing against using a dictionary. I just thought that yeah, I just write a switch statement to switch it up, right? So that's what I'm gonna do. So in essence, all we're doing is assigning a numeric value to represent the precedence sort of level, and the higher number, the higher precedence. That's how this algorithm works. So instead of doing this part where it's initializing this map, I'm not gonna do that. I'm just gonna implement this this get toke precedence function. Although if you wanted to follow along with the tutorial exactly, then you're more than welcome to do that. I'm actually not even gonna bother doing this. I'm gonna say switch cur toke. If it's the less than sign, then I'm returning 10. Probably do the same with the greater than sign. I don't understand why, if you're gonna do a less than sign, you're not gonna do the greater than sign. I'm doing the greater than sign. If it's the plus sign, then whoopsies. Okay, if it's the plus sign, returning 20. Minus sign, also return 20. If it's a multiplication sign though, we're returning 40. Might as well do the division, huh? Why not? Why would you do multiplication but not division? And in the default case, we're returning -1. Okay, so -1 will for sure be smaller than any of these, and it will actually be smaller than 0, which is actually significant, as you will see in the next part. Alright, now we're ready to write this parse expression function, it looks like. So let's write it. I'm going to parse a primary. and which will, again, a primary is either a number literal, an identifier, or an expression that's been closed in parentheses. And if we were able to parse it, then, or if we were not able to parse it, then we're returning null, or null pointer. But if we were able to parse it, then what we're gonna do, honestly, I don't like this way, this sort of negative case first thing. I'm gonna reverse it. It's just not my style. We're gonna, so yeah, if we did manage to parse the left hand side, we're gonna do, we're gonna call parse the binary operation. We're gonna parse the right hand side of it. And it looks like we're gonna move the smart pointer in, probably into that function. That's probably, does it talk about this move? No, it kind of doesn't talk about this C++ stuff. It assumes that you already know it. Okay, now we're gonna write this parse bind up right hand side. I'm gonna explain what this is. Okay, so given a precedence, this press stands for precedence. Everything is so abbreviated. So this is a precedence number here. A precedence number. Excuse me. Which is a number that's 0 or greater. 0, I mean, every operator will have a number, a precedence number that's greater than 0. So by initializing to 0, what you guarantee is that any actual operator will be recognized as having greater precedence than the initial precedence level. And here we're gonna say there's a while loop. Oh, we're gonna keep parsing the right hand side. I think that's what's happening, maybe. So this is saying if this is a binary operation, find its precedence. Okay, get its precedence. So we just parsed the left hand side, and so now we should be staring at a token that is an operator, like a plus sign or something. Get its precedence, and if its precedence is less than the current precedence, which is this expert precedence, which you'll see why that number actually, comparing with this number, is actually meaningful, I think, later. But if it's less than it, we know that we're kind of ignoring it, ignoring the next operator, and we're just gonna return the left hand side. Again, we'll explain that later. This code gets the precedence of the current token and checks to see if it's too low. So if it's too low, we're not gonna grab the right hand side, as in if we have some mysterious thing and then +2, and whatever this mysterious thing, its precedence, let's say, was really high, like 90. It has a precedence, it has an expert precedence of 90. therefore the precedence of a plus sign is too low. I think the precedence of a plus sign is only 20. So the precedence of a plus sign is way too low. So it's like, no, ignore. It doesn't bother taking in the rest of this stuff, and just returns the left hand side as its own thing. That's what this if statement says. We'll see why that fits into the big picture later. This check implicit knows that the pair stream ends when the token stream runs out of binary operators. If this check succeeds, we know that the token is a binary operator. As in, I think that by token, I think it means this left-hand side is already a binary operator, because unless it was already a binary operator that had a higher precedence than the plus sign, this condition cannot possibly occur. So that kind of means this mystery thing is probably something like 2 times 3, because how else could it have a higher precedence, right? Okay, so now, okay, we know this is a bin up. Get next token. Wait, where does this code go now? I guess it's saying, so if else, if it didn't return from it, now we know this is a bin up. Does it actually know? We're gonna get next token to eat the bin up. And then we're gonna parse the primary as its right hand side. And I guess if there is no right hand side, then return the null pointer. Again, I kind of don't like this negative testing, negative case first kind of style. As such, this code eats and remembers the binary operator and then parses the primary expression that follows. This builds up the whole pair, the first of which is plus b for the running example. Now that we parse the left hand side of an expression and one pair of the right hand side sequence, we have to decide which way the expression associates. In particular, we could have a plus b bin up unparsed, or a plus and then in parentheses b bin up unparsed. To determine this, we look ahead at bin up to determine its precedence and compare it to the bin up's precedence, which is plus in this case. So, okay. So if I'm gonna do this positive case first. Okay, so basically it's saying if we were able to manage to parse a right hand side, see if the next one is also a binary operator. I think that's what that means. So it's like if we have 1 plus 2 times 3, we already, I got that as the left hand side. I got that as the right hand side. But we're gonna look ahead to see if this next one is also a operator, which has even higher precedence than this one, which in this case it does. In this particular example, it does. So the next precedence, the precedence of the next token, if the toke press, which is the previous operator's precedence, if it's less than the next operator's precedence, Then we know the parentheses associate as a plus b bin up. Loop around at the top of the while loop. So let's see. I think this is the case where it says if body omitted. Oh, I guess it would be the other way? I'm actually kind of confused. I'm going to copy this line. I'm not sure this is in an example. So in our example, into first a plus b and execute the next iteration of the loop with plus as the current token. Okay, let me see if this, let me finish reading this. A critical question left here is how can the if condition parse the right hand side in full? In particular, to build the AST correctly for our example, it needs to get all of C plus D times E times F as the right hand side expression variable. The code to do this is surprisingly simple. Code from the above two blocks duplicated for context. So this, I have this line, and then if the toke press is less than next press, then I was actually want to parse the right hand side. I did not have that line. If not RSH, then return null pointer. And you're saying this guy should come out of this if statement. Is this right? This looks kind of complicated. One thing I don't like at this point about this tutorial is I'm not instructed to test each of these functions as I write them. So, and I feel like this is a place where I want to verify that the code I have is correct. Now I could scroll to the bottom and just get access to the code, but I kind of want to figure it out myself as well. Let me think. So if I had an example like 1 plus 2 plus 3, oops, that looks ugly. So what would have happened is we first start at parse expression, and then parse primary would have consumed this 1. And then after 1 was consumed as a primary, so 1 went into the left hand side basically. I'm gonna call we're gonna move this current token cursor to this plus sign and call parse bin up right hand side. Parse bin up right hand side, I think it's always gonna be called when the next token is a well, not necessarily, but supposedly it's called when the next token is an operator. And so let's suppose it is. It's gonna say, what's the precedence of this operator? It's gonna turn out to be 20 for the plus sign. And then because we started this at 0, well, 20 is not gonna be less than 0, so we're gonna keep going here. And the current token is gonna be the operator, and we're gonna consume that, and then we're gonna try to parse the right hand side, that will get parsed as the primary. Left hand side, which was previously parsed but passed into this function, and we also have the right hand side. And now we're gonna say, well, if we got a right hand side, we actually need to keep looking ahead to see whether we should go ahead and group these guys together or not, or whether maybe we need to group these guys together, because if this was a multiplication sign, we actually need to group these guys together first before we group ourselves together like that. But because in this example it's a plus sign, has the same precedence as the previous one, we should just group these guys together. See if this code actually does that. So we're gonna see the precedence of the next one, which is also gonna be 20. Is 20 less than 20? No. Therefore it should jump to here. Why does this assign left hand side? Oh, I see. Yeah, this line groups these guys together. It makes a new binary expression AST with the current left hand side and the current right hand side, which was here and here, and groups this together and says this is the new left hand side. So this is correct. So if the precedence is not less, or if the precedence of the next operator is not strictly greater than the precedence of the previous operator, then we're going to group the current left hand side and right hand side together and call that the new left hand side, and then go back to the top of the loop. However, all right, let me clear this out because this is getting too messy. However, if we had a multiplication sign here, then the next precedence would be 40, and the toke precedence would be 20, and therefore it would actually take this path. And if that happened, we're actually gonna try to sort of parse this part with right hand side, set the precedence to the current one plus 1. Interesting. So like 21. Oops, 21. We're gonna move the current right hand side. We're gonna move the 2 into its, so 2 becomes the left hand side of this. Yeah, I'm gonna try to parse it and have that as so basically we want this guy to be the new right hand side, and that makes sense. So this makes sense to me. This checks out. Yeah. So let's go for that. And if we did parse a new right hand side, then that's the one we use to combine it with the old left hand side. But if we didn't get a new right hand side, we return a null pointer to represent erroring out. Okay, so that's how it works. All right, so how much more is there to this code? I think we can probably finish this. So let's go ahead and parse the rest. I hope this is not too much longer. I hope I gave a good explanation of this operator precedence, and I hope I can get it to work. Let me just keep an eye on the clock. How long have I been at this? 25 minutes. Actually, that's quite long. Yeah, actually I'm gonna stop this one and leave the parse the rest for the next video. I will see you on the other side.